of matter. The first topic is elasticity. According it is a man grows into a giant such that his linear dimension increases by the factor of 9. It means suppose the man grows, therefore the stress will change. But here the density remains constant, remains same. Then we know stress. The stress is equal to the weight or mg upon cross section area. All linear dimension increases by 9 times. Then we know mass equal to volume into density, then the mass is proportional to volume, and volume becomes, we can say, new mass becomes 9 times of linear dimension, means 9 to the power 3 into initial mass, because volume equal to area of cross section into, या यूँ कहते हैं कि volume in the meter cube, and as well as the area. The new area is equal to, area means it is area dimension is a meter square, so it is 9 to the power 2 into initial area. तो न्यू स्ट्रेस, अगला नया स्ट्रेस जो आएगा दैट विल बी द 9 to the power 3 upon 9 square times of initial stress. Therefore it is a 9 times of the initial stress, so stress becomes 9 times. So correct option is a third one. Next one is a steel cable which can bear the maximum stress is not exceed to 10 to power 8. Then we know stress equal to the load upon cross section area. Then the maximum load which can bear by the cable equal to the stress is a 10 to power 8, and the cross section area is a radius is a 1.5 centimeter. So it is a pi into 1.5 into 10 to power minus 2 square, pi r square. So that is a maximum load on the steel cable is equal to 10 to power 8 multiplied by 2.25 pi into 10 to power minus 4. And we know the product of the 2.25 and pi is almost 7. So it is 7 into 10 to power minus 4 Newton is a maximum force. So the 7.06 means 7.1. So the third option is correct. Next one, the two wires of the same material. Same material means the Young modulus of elasticity is the same, and the length but diameter are in the ratio is a 1:2. They are stretched by the same force, means the force is same. Then ratio is a potential energy per unit volume, and we know the potential energy per unit volume is equal to half into stress that multiply by strain. So we can say it is a half into, we know strain equal to stress by y, so stress square upon y is the potential energy per unit volume, that is energy density. So the ratio of the potential energy per unit volume means the ratio of the stress ka square. So energy density of the first to the energy density of the second is equal to the stress in the first wire to the stress in the second wire. But the force same, that means the stress equal to force upon area, where the area is the pi into radius square or a diameter square. So the diameter of the first one is a, suppose d1 square, e1 is inversely proportional to d1 square, and it is a e2 is inversely proportional to d2 square. Then we can say ratio of the energy density is a d2 by d1 to the power 4, and the d2 by d1 is a same in the ratio of the radius, so it is a 2:1 inverse. 2:1 means 2 by 1 to the power 4, so it is a 16:1. So correct option is a fourth one. Both the wires have equal length, equal diameter, same diameter है, connected end to end. End to end means both are connected in the series. then we can say having same stress same रहेगा, it means strain भी same रहता, स्लोप भी सेम रहता, बिकॉज y सेम है, तो ये तीनों भी, बट one of them is a copper and another is a steel, then we can say the force will be same, therefore the force will be same means stress will be same, but due to different material, one of them is steel and other is a copper, strain is not same and the y of the steel is not equal to the y of the copper, so only first one is correct. Pressure is required for the 1 liter water will be changed to compress it by 0.1%. Then we know the required pressure is equal to delta V by V and multiply by bulk modulus of elasticity, and here given delta V by V per delta V by V volume change in percentage in the volume is equal to 0.1. Therefore the volumetric strain is equal to 10 raised to power minus 3. Then what is the required pressure for this? If the bulk modulus of elasticity is at 2.2 into 10 raised to power 9, it is multiplied by 10 raised to power minus 3, so it is 2.2 into 10 raised to power 6 Newton per meter square is required. So the correct option is the third one. In this condition, the aluminum cube is a 10 centimeter long. One face is a firmly fixed in the vertical wall. That is a fix in the vertical wall. The side is a 10 centimeter and the weight is suspended is 100 G. Then the tangential force upon area is equal to neta, that multiply by tan theta. The deflection of this side is a x, then x into a side is a 10 centimeter. Then we can say F upon A shear stress equal to neta x upon side is a small a. Then force equal to 100 G upon area is a 10 raised to power minus 2 and neta is a 25 into 10 raised to power 9 because gigapascal, that is x, and that is multiplied by 10 centimeter means 0.1. So the deflection x equal to 10 raised to power minus 3 sorry it is 10 raised to power 2 means 10 into 10 raised to power minus 9 upon 25. It is 10 raised to power minus 5 and minus 7 100 by 25. If G is not a 10, it is G is suppose 10, so it is equal to 4 into 10 raised to power minus 7 in the meter. So I think the correct option is third one because we will take here the G is a 10. If G is a 9.8 then the 4 की जगह 3.92 हो जाएगा. So correct option is the third one. In this situation, the maximum force that can be applied on 3 kg that can be applied on 3 kg so that the wire does not break, but the wire's breaking stress is a 2.5 gigapascal. So suppose the tension in the string is a T, therefore T upon cross section area is equal to 2.5 gigapascal, it is 10 raised to power 9 Newton per meter square. So maximum tension in the wire is equal to 2.5 into area is a 4 into 10 raised to power minus 8 into 10 raised to power 9. Therefore it is a T maximum is equal to 100 Newton If the T is 100 Newton, that means the acceleration of this block is a is equal to 100 by 2 is a 50. Therefore F equal to 5 into 50. 50 is the acceleration, total mass is a 5, so the maximum force is a 250 Newton. यदि maximum force 250 अप्लाई करेंगे तो टेंशन इज 100 and the wire will break. So the maximum force पूछा है, so the correct option is a fourth one. Given problem, we know the elastic wire behaves like a spring and we want to find the calculate the elastic potential energy. दोनों सीरीज में है, elastic potential energy कैलकुलेट करना है. Then elastic potential energy according spring, it is equal to half k x square. In terms of force, if we multiply k numerator and denominator, then we can say the elastic potential energy is a F square by twice of k. K is a elastic constant. In this situation we calculate according spring की तरह यदि मैं इसको सॉल्व करता हूँ तो मुझे पता है कि दोनों में फोर्स सेम रहेगा. Force is a weight which is a suspended, so we can say weight square upon 2 of k. K is a elastic constant or it is a k equivalent. Here we know the k of the lower wire is a ya upon L and the upper wire is a k2 equal to y, but the radius double है, it means area 4 time होगा, so 4ya by L. So it is a k and this is a 4 times of the k. Both are connected in series, then we know k equivalent is equal to k1 k2 upon k1 plus k2. So it is a 4k into k upon 5, 4k square upon 5k, so it is a 4k by 5. So k equivalent equal to 4 times of ya by 5 times of the length. I again repeat, जस्ट स्प्रिंग की तरह सॉल्व करें तो इट इज हाफ के एक्स स्क्वायर, बट द फोर्स सीरीज में फोर्स सेम है. इट मीन्स इट इज अ एनर्जी इज इक्वल टू फोर्स स्क्वायर बाय 2k. के की जगह के इक्वलेंट लेते हैं. इनका इलास्टिक फोर्स कांस्टेंट इज अ ya by L and 4ya by, and we know the area is equal to pi into r square. Then suppose the elastic potential energy of the system की बात करें तो वेट का स्क्वायर upon twice of k equivalent is a 4y, area is a pi r square upon 5 times of the length. So elastic potential energy in the both the wire is a 5 times of the elastic potential energy is the 5 times of the weight square length upon 8 y pi r square. That is the elastic potential energy in the whole system. So according this one is a correct option is a 5 by 8. Third one is a correct. Bubble is rises from the bottom of the surface of the lake. Its radius becomes r2 5 r by 4 and the atmospheric pressure is equal to 10 meter height of the water column. So what is the depth of the lake? Any depth of the lake find करना. Suppose the depth of the lake is a d. That means at this level it is a p naught. At this level is a p naught plus d rho of water into g. बट इट इज़ अ टोटल प्रोसेस इज आइसोथर्मल प्रोसेस में टेम्परेचर हम कांस्टेंट ले सकते हैं. टेम्परेचर यदि कांस्टेंट लेते हैं तो प्रेशर एट द बॉटम इंटू वॉल्यूम एट द बॉटम इक्वल टू प्रेशर एट द टॉप इंटू वॉल्यूम एट द टॉप. देन वी नो द प्रेशर एट द टॉप इज अ 10 times of the rho of water into g, but at this level is 10 plus d into rho of water into g. At this level the radius is r, but at this level is a radius is a प्रेशर कम हुआ तो रेडियस बढ़ा है, वॉल्यूम बढ़ा 5 r by 4. Then we know pressure is a 10 plus d, then the volume is a 4 by 3 pi r cube. At this level is a 4 by 3 pi r cube, and that is multiplied by 5 by 4 times, means 5 cube upon 4 cube. Then we cancel with the all terms. Then the 10 plus d is the depth of the leg. 10 plus d equal to 10 times of 125 upon 64. So the depth of the leg is equal to 10 in the bracket 125 by 64 minus 1, and that is a 10 into 61 by 64. So it is a 610 by 64 is equal to 9.53125 meter. That is the depth of the leg. So the correct option is the third one. पूछा है कि work done in increasing the length of the 1 meter by 1 mm. I think इसको भी स्प्रिंग की तरह हम सॉल्व करें. then work done is equal to half k x square, and we know the k for this wire is a ya by l. Then work done to increase the length is a half into k. K means ya by l, into x. X is a elongation. Elongation is a delta l. Then we can say work done is equal to half into y. Y into 2 into 10 raised to power 11 into area. Area is a 1 mm square, means 10 raised to power minus 6 upon length is a 1 meter, and delta l is a 10 raised to power minus 3 meters. So it is 10 raised to power minus 3 whole square, 10 raised to power minus 6. If we solve this one, then it is a 10 raised to power minus 1 joule. Therefore the correct option is a 0.1 joule, and the first one is correct.